Okay, so this is going to be less than 6.5. And we're going to go through a little activity here. And so how do we solve a quadratic equation? That's where we're starting out here. What does the solution mean? How are the solutions weighted when they are presented through the numerical, graphical, and algebraic methods? So what's going on here? Well, we're going to look at this example right here. We're going to solve this quadratic equation, x squared plus 5x minus 6 equals 0. Okay, and there's three methods for solving quadratics. This is the first one. And we're going to look at it and see what this means. What does a solution mean when I ask you to solve? Okay, so just like in the past, in the earlier lessons when we learned how to solve linear equations, we separated the two equations out. So we did it as two separate functions. So we're going to look at this side over here as a function y equals x squared plus 5x minus 6. And then this side is another one as y equals 0, the horizontal line, also known as the x-axis. And we're asking the question. So what x value or values, because there could be more than one, does this function equal 0? So when does it equal 0 in a graphical sense? Okay, so from the graph. So let's graph it. Okay, we're going to graph these two functions out. And let's go ahead and do that. So we have the equation. I'm going to write it down again so we can see it here. We have y equals x squared plus 5x minus 6. And then we had y equals 0. So the y equals 0 is just the horizontal right here. This is the y equals 0. Okay. And then we need to graph this. So how do I graph that again? Well, we need to find what? We need to find the vertex. So because it's in standard or general form, we want to use the negative b over 2a approach. Over 2a. A is 1, b is 5, and it looks like it's a negative 5 over 2. So I know that's where the vertex is. So right in the middle over here in our table, looks like it's about right here, 5 over 2, which is basically a negative 2.5. Okay? And so we can use all of our calculators or whatever we need to do. And that's what I'm going to do, is I'm going to go over here and use my calculator to assist me. And we're going to graph x squared minus 6 and negative 2.5. So at a negative 2.5, we have a negative 12.25. And so we want two numbers above and two numbers below. So this is a negative 2.5, so we're going to go negative 3 and negative 4. And then this will be negative 2, negative 1, and we'll do 0 because I already know at 0 it's negative 6. Okay? And so we can do those, and then we type in these numbers. Negative 2, this is going to be negative 12. Negative 1 is negative 10. So negative 3 is the same values. Negative 12. There's negative 10. And we can keep on going. Let's see, we got another room here for 1. And we'll do negative 5. We'll see what we get there. 1 we get as a 0. And negative 5 we get as a negative 6. Okay? So if I continue this pattern here, we can see then probably this one over here is going to be 0 also. Negative 6 is going to be 0 also. So then I can come over here and I can graph these things out. And so based off of this, we have a very, very weird scaling going on here. So to get down to negative 12, we're going to need to come down here. This is going to be by negative 6. This will be negative 12. Okay. And then 6 and 12. And then we put these numbers here. Here's 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. Okay. And negative 6. So based off of this and our scale right here, we come over here and we type in all these numbers that we have. 1 is at a 0. 0 is at negative 6. At 2, we're at negative 12. At 3, negative 3, we're at negative 12. 4 is at negative 10. 5 is at negative 6. And negative 6 is at 0. And we have a quarter right about there. So based off of this shape, and we can type in some more numbers if we needed to, just for clear out the shape. And 2 is going to go to 8, which is roughly right about here. It's coming down like so, then coming off over here. And it just keeps on going in that fashion. What's important for this picture, though, is when does it cross? When do these two functions cross each other? One, remember, was the horizontal axis, so when y equals 0. And so where does it cross? It crosses here, and it crosses here at 1 and -6. Those are the x-intercepts of the graph. So what we're finding out here in this process is that the x-intercepts are indeed the solutions. Okay, when is this graph right here? When is this equation equal to 0? When is this graph equal to 0? It is when it crosses the x-axis, because that's where y is equal to 0. So the x-intercepts are the solutions, or in this case, where the two sides intersect. Okay, on the graph, they're the x-intercepts, what we just said. What are the solutions to the quadratic equation right here? We can see then, what are the solutions? The solutions are when x equals 1 and when x equals -6. These are your two solutions to this equation. If I take these numbers and plug them in, 1 squared, 5 times 1, -6, I'm going to get 1 plus 5 minus 6, which is indeed 0, confirming that it is indeed a 0. Okay, and the same thing will apply if I plug in -6. Plug in -6, square it, 5 times -6 minus 6. This is 36. This is a -30, minus 6, 36 minus 36. Sure enough, that is also 0. So this is what's going on. So when we talk about quadratic equations, we're asking, when does the graph cross the x-axis? Those will be my solutions. So if a graph quadratic equation does not cross the x-axis, then you have no solutions. If it comes down and touches the graph in one spot only, like if the vertex is on the x-axis, then it'll have only one answer. Okay, so that's the relationship that's going on here. And so because these are x-intercepts, we have a form that shows me the x-intercepts, the intercept form, or factored form. So a technique algebraically to solve these equations, this equation right here, is by using the factoring technique. If I take this thing right here, make sure it's equal to 0 first, and I factor this, okay, then I take the factors of 1, the factors of 6, and 6, 2 times 3, and I'm looking for a method, factors that will subtract and give me a 5, so I'm going to go with those right there. So a 1 times 1, and a 1 times 6, 1, 6, and if I make that a plus and then a minus, then I get a positive 5. And so then this thing right here will factor into x and x. Factors, those are those in the front. The 1 and 6 go in the back. I need the 6 to be positive, the 1 to be negative, so that's the positive 1. This is the negative 1. And so it's factored form. And if they are factored and is equal to 0, then I have a property. How do I get to these answers at the bottom? It is called, right here, the zero product rule. If you have a product of two numbers that are equal to 0, then either the first number was 0 or the second number was 0, because that's the only way you can multiply two numbers and get a 0. One of them has to be 0. And since we don't know which one, we say x minus 1 can be 0, or x plus 6 can be 0. And you solve each of these individual linear equations, add 1 to both sides, or x equals, subtract 6 from both sides. And you can see right there, x equals -6, x equals 1, 1, -6. There's my two x-intercepts. And here's the two confirmed answers that we said were going to be the solutions when I plugged them in numerically. So everything comes together just like it did before in previous lessons. The same thing applies in quadratics. Okay? And so that's what we're going to be doing. So again, the zero product rule is what allows me to use the factoring technique to find the zeros. You can also look at it this way. What number makes that 0? What number makes that 0? The same process. That's what we're doing. So with that, let's go practice some of these examples. So I'm going to start off with this one right here. In the time that I have, we're going to do this first one, number 1. And so we want to use a factoring technique and then confirm it graphically and algebraically or numerically by just plugging the numbers in. So I'll do it over here. Oops, I lost all my lead. So x squared plus 3x minus 28 equals 0. The thing here to remember is before you do any kind of factoring technique, it has to be equal to 0 first. You must make sure all the terms are on one side before you attempt to do any factoring technique or any of the techniques I'm going to show you for solving. It has to be equal to 0 first. Okay, so once I have that, I know I'm going to factor this if I can. And if I can't, then that means it never crossed the x-axis. I got the factors of 1 and the factors of 28, 1 and 28, 2 and 14, and 4 and 7. I'm looking for numbers that will subtract and give me a 3. But since there's only a 1 and 1 on the front end, I'm going to be using 7 and 4. 1 times 4, 1 times 7, that's 4, that's 7. And I need a positive 3, so it has to be in that fashion. That gives me my positive 3. So the x's, 1 x is going in the front, the 4 and the 7 in the back. But the 7 has to be positive, the 4 has to be negative. That's the negative, and that's the positive. So now I can use the zero product rule, which says I have a product of two terms, two things that equal to 0. So the first thing can be 0, or the second value number can be 0. And then we solve each of these individual linear equations. In this case, we're just going to subtract 7 from here. So we'll get x equals -7. Or we add a 4 here, and x equals 4. And so those will be my two solutions. And we can confirm those algebraically by plugging them in. -7 squared plus 3 times -7 minus 28. Does that equal 0? And so this is 49. This is minus 21 minus 28. And it indeed confirms to be 0. And you can check the 4 also. 3 times 4 minus 28. Does that equal 0? This is 16, 12, and sure enough, they also confirm to be equal to 0. Okay? And so then we can go through and we can solve and show that these are indeed the solutions graphically. Okay? And so what I need to do is I need to come over and we need to make a table for the equation. So we got y equals x squared plus 3x minus 28. And y equals 0. We're going to graph both of those. This is just the x-axis, so I need a table for the first one. And we need to find its vertex. So negative b over 2a gives me a negative 3/2. So a negative 3/2 goes in the middle. And we need to figure out what that number is. And for the sake of time, I've already figured it out. It's going to be a negative 30.25. So we need two numbers above and two numbers below. Okay. And this is a negative 1.5. So we got what? Negative 1 and 0. And then negative 2 and negative 3. And if I plug these numbers in here, this is going to be negative 30. And negative 2 is going to be negative 30. And 0 is going to be negative 28. And this one over here will be negative 28. And you see that we're really, really far away from things. Okay? But I also know these numbers. Okay? I know that if I plug in a 4, since I did plug it in, I know I'm going to get a 0. And I know because I plugged it in, if I plug in negative 7, I'm going to get a 0. So at negative 7, I have 0. And there's some numbers in between, but let's go ahead and take a look at this and graph this so you can see how it lays out. And so I already know these answers. So at 0, I'm at negative 28, so way down here. So at 0, I'm at negative 28. At negative 1, I'm at negative 30. At negative 2, I'm at negative 30. And then right here, I'm at negative 30 and a quarter. Negative 28. And then I've done some other numbers, and I'll go ahead and tell you what these are. 1 is at negative 24. 2 is at negative 18. 3 is at negative 10. And 4 is going to be at 0. And 5 is going to be at 12. So I already figured all those out for us. And then these just have the mirror image over here. Right here will be at negative 24. And then this one mirrors over here. And then this one mirrors over here. And then this one mirrors over here. And so there's my parabola. And you can see that it all is going to match out nice and pretty. And my lead is dead. And then we graph this side. Okay. And we can see that this here is my y equals 0. And this is my y is x squared plus 3x minus 28. And they intersect at these two locations right there at x equals 4 and at x equals negative 7. Confirming then, because the x-intercepts then are my solutions. Okay, so the graphical technique. And so the graph of a quadratic where it crosses the x-axis would be the solutions to the equation where it's equal to 0. Okay, we can get those in factored form. So a factored form is the technique we're going to be using to help us, one of the techniques we're going to be using to solve our equations. You should always check your answers at the end to make sure you have the right answers by plugging the numbers in, and it should work just like this. There's no reason for you to get an answer wrong in quadratics because you've got to take an answer, you plug it back in the original, and if it works, you know you have the right answer. If it doesn't work, you know you don't. That means you made a mistake in factoring or something along those lines. So that's this lesson. Let's do a couple more examples in this video, or at least one more example in the video, and then we'll move on from there. So I'm going to do this one right here. Number 3. I have 5x squared minus 3x minus 26 equals to 0. So we're going to try and factor this out. Hopefully it does. So we got the factors of 5, and then the factors of 26, 1 and 26, 2 and 13. Okay, we got to figure out a way to get to negative 3. I'm looking at this pair right here and this pair right here. I'm going to do the 5 and 2 is 10. So I got 1 times 13 and 5 times 2. Here's 13. And this is 10. If that's negative and that's positive, that gives me the -3 that I'm looking for. That means these numbers go in the front and those numbers go in the back. So I have 5x and x. And the 5 has to multiply to the 2, so that means the 2 has to go back here. The 2 has to go back here, and the 13 has to go there. I want the 10 to be positive and the 13 to be negative. So by our zero product rule, you take each factor, you set it equal to 0. We solve each individual equation for x. I'm going to add 13 and divide by 5, so x is 13 over 5. And then this note here, subtract the 2, and so I get x equals -2. So these are my two solutions, okay? And for the sake of time, I'm not going to check them, but I know that they will work. And so those, you circle those and get your answer. Now, I want to talk about the vertical motion problem in this video. There are certain word problems, and I'm going to do this in each video. We'll do a different type of problem. Today's problem is the vertical motion problem. Okay? This is your projectile motion. So any object that is being thrown, tossed, shot out of a cannon, anything like that, follows this formula. This formula right here is a formula that will determine the height of an object over time. Okay? That's what this formula is for. So if I'm on the top of a building and I drop a coin, it follows under this motion right here. Any object that is dropped or shot or thrown or anything like that. H is the height of the object. T will be the time in seconds. This V sub 0 represents the initial velocity of the object, and H sub 0 is the initial height of the object. If the object is being propelled upwards, then V sub 0 will be positive. And if it's being dropped downward, so not dropped as a bad word, thrown downward, then it would have a V sub 0 will be negative. That means you have a negative velocity. If I have an object that is just dropped, I just let go. Okay, like dropping a coin without any kind of movement up or down, just letting go, then V sub 0 will be 0. There is no initial velocity. Okay, so we can write that down. So if the object is dropped, then V sub 0 will be 0. Okay, so that's something to keep in mind. So we're going to do a problem based off of this. Okay, and I'm going to show it to you right now. So we're going to look at this problem number 6. Okay, it says you jump off the high dive platform at a city pool, which is 12 feet above the water. You jump upward with an initial velocity of 4 feet per second. How long will it take you to enter the water? And so it's helpful if you have a little picture here. You can actually see this happening. So here is the pool. So here's the pool down here. This is your pool. Okay, here's the platform. Here you are. And you're going to jump up and then come down. So you're jumping up and then you're going to come down. So you can see why, and then you're going to splash right there. So you can see why this is a quadratic. And so what information do we have? Well, we know that you are 12 feet up, and you know your initial velocity is 4 feet per second. And since you're jumping upward, then we know that that is going to be a positive 4. So the first thing you do is you take this information, you plug it into this equation right here. So we'll have h equals a negative 16 t squared plus 4t, and then plus 12. So that's how you get your equation made. And then I can determine how much time it takes to go into the water, because if I hit the water here, this represents the 0. This is like the x-axis right here. Ground level will be the x-axis. And I can figure out that solution here where it intersects the pool or the ground, which means the height of the object is at 0. So when is it hit here? When negative 16t squared plus 4t plus 12 equals 0. When the height is 0. That's when it hits the pool or the ground. That's what that means. So when I'm solving this, I need to factor this. So the first thing I do in any factoring problem is look for a GCF. And it has 1. And because this is negative, I want the square term to always be positive. I'm going to factor out a negative value. And the biggest number that goes into all three of these things will be 4. So it's going to be a negative 4 is coming out. So this leaves me with 4t squared minus t minus 3. And you double check to make sure everything, when I multiply back out, I get back to that right there. We want to factor this even more. So we're going to do factors of 4 and 3. So for 4, we got 1 and 4, 2 and 2. For 3, we have 1 and 3. It's only one set there. I need to subtract to get a 1. So I can use these sets right here. Okay. And I get 1 times 3 and 4 times 1. There's the 3 and the 4. They need to subtract and give me negative. So that's how that's going to work. So 4t here, 1t here. The 4 has to multiply to the 1, and so this multiplies to the 3. I want the 4 to be negative, the 3 to be positive. And so there's my factoring. Because it's equal to 0, these two numbers can be equal to 0. This is never going to be a 0. So I have 4t plus 3 equals 0, or t minus 1 equals 0. Solve each of these out. Subtract the 3, divide by 4, so t will be a negative 3/4, or t will equal 1. So now we have an interesting story here. So what's happening? There's two answers, okay? But which one doesn't make sense? This one does not make sense in this context of this problem, because t represents time in seconds. So the question is, when I jump off the platform, when do I hit the pool? Well, this number in that context means that you hit the pool before you ever jumped. And that's not what we do. So this one is not a solution, even though it popped out of the equation. It does not meet the concept of the story. Okay, it's basically the bottom end over here. So this part over here, this is a parabola. Okay, and it's talking about this part down here, but see, that's going back in time, and we're not doing that. So t equals 1 is the solution, and you write it as what? When will you hit the pool? You will hit the pool, or what was the question that's asked for? Was what? How long will it take you to enter the water? You will enter the water at 1 second. And t is 1 second. So once you jump, you're going to hit that water in a second. And that's how you answer that question. This is an initial velocity problem. And so therefore, make sure you practice this one. It is a potential test question. We'll do more questions together in class.